skeletons and their owners, it's me, BiaSciLab, ready to teach you how to build your own home lab. But first, who am I? I'm a 13-year-old girl. I was the youngest speaker at Hope. Hope is one of the oldest hacker conferences. I am a 3-time speaker at DEF CON. I spoke at the Roots Asylum, the Voting Village, and the Biohacking Village. I also spoke on election security at DEF Camp in Romania. I am the founder and CEO of Girls Who Hack. Their motto is teaching girls the skills of hacking so that they can change the future. I provide physical and virtual lessons to any girl who wants to start her journey in cybersecurity. I am a maker and a hacker, and my election hacking was highlighted at a congressional hearing on election security. So let's get started. So why build a home lab anyway? Well, you don't have to use your family's computer. You can start a project, leave it that way, go to soccer practice, and come back and continue. You can set up special network situations for any project you're working on, and no one else will mess with your stuff. You need a dedicated space. It can be just a desk in your room. It can be in the attic, the basement, your bedroom, the garage, anywhere you have a little bit of free space. Here are the things you'll need to make your at-home network. First, you're going to need to get a router. A router allows your computer to talk to other computers and the internet. You can get a used one from a garage sale, from your family, friends, or eBay. You'll also need a switch. A switch tells all the little tiny packages of data, or packets, where to go. You'll need to get a switch if your router doesn't have one built in already. You can either get a managed or an unmanaged switch. A managed one lets you do cool stuff like VLANs and packet captures, whereas an unmanaged one just lets you send the packages around. So how do you even get all this stuff? You can ask your parents' IT department at their work. Companies usually just throw away old computers and laptops and perfectly good things. Same with schools. You can get things from garage sales. My neighbor found an old Alienware laptop and just gave it to me, and now I use it all the time to play games on. And you can always ask other hackers. Most of them just want to help out the next generation. Do you want a physical or a virtual lab? A physical lab is where you have old computers running lab software. A virtual lab is where the software runs on a virtual machine. Physical. For a physical lab, you need to install the operating system and software on a physical machine. Now let's cover some pros and cons. Pros. It's less limitations on memory and processor power. It's easier for packet captures, and it has less complicated networking, so you don't have to worry about that. But cons. It takes up a lot of space, especially if you have more than 1 or 2 machines. It has difficult restore points. You can't just go back to an earlier snapshot. You have to restart everything if you mess up. And it's hard to move around. If you decide to go travel or go on vacation or go somewhere, it's pretty hard to carry around a bunch of machines and laptops. Now, virtual. What is a virtual machine, you may ask? It's a computer that runs inside your computer. It's just turtles all the way down. Parts of a virtual machine application. There's the host machine, which is your computer or your laptop. Then there's the hypervisor. This application controls all of the virtual machines. It controls their starting and stopping, their memory and processor, their storage and network, and it can only run as many virtual machines as your host computer can handle. If you have just some resources, you can't give it all away to every single virtual machine, or else you have nothing for your host computer to run on. So don't forget, leave resources for your host to run, or else it's just going to freeze. Now for the pros and cons. Pros: you can use it on your normal laptop, and it allows you to run a lot of machines on just one computer. And it's very, very portable, so if you decide to go on vacation or go somewhere, you only need to take one laptop instead of a bunch. Cons: you're limited by your computer's memory and processor core. Like I said before, there's only so much it can give to all of the virtual machines. And it has very complicated networking. I know what you're thinking. Well, Bia, should I do physical or virtual? Well, why not both? On the left is Alice, connecting to her router wirelessly. She is running a couple VMs on an old tower and Windows XP on an old laptop. So now let's install a virtual machine. You should have downloaded and installed VirtualBox, and you should have downloaded Ubuntu 18.04. Now here are some cool Ubuntu facts. Ubuntu runs many of the servers on the internet. 18 is the year of the release, and 04 is the month of the release. Okay, now we're going to open up VirtualBox. After we open that up, we're going to click on the little round star blue thing that says New and create our own virtual machine. Next, we need to name the operating system. We're going to name it Juice. And for the type, we're going to choose Linux. And as for the version, we're going to use Ubuntu 64-bit. Then press Next. Now for the memory size. Give it about 1024 megabytes. When you're done with that, click Next. Now we're going to choose Create Virtual Hard Disk Now, and we're going to click on Create. We're going to make sure it's VDI. Now we're going to choose Dynamically Allocated and Next. Then we're going to name it Juice again. Then we're going to give it 28 gigabytes and create. And ta-da! You have a virtual machine. What's in this virtual machine? Nothing! Absolutely nothing! So let's add an operating system. What is an operating system? An operating system is a program that controls and manages all the hardware on the computer. What has an operating system? Your tablet, smartphone, laptop, computer, smartwatch. You may have heard of some of these operating systems: Windows, Mac OS, and Linux. So let's install a server. A server is a computer designed to process requests and deliver data to another computer over the internet and a local network. We're going to be using Ubuntu 18.04, and that is a very popular Linux server. Much of the internet runs on Ubuntu, like I said earlier, and it has tons of support forums online. So if you're ever confused or want to learn more about it, there's a lot of information. Next, we're going to go and select Storage. inside of storage, we're going to go to Controller IDE, click on Empty, go to the little tiny disk over here, and choose Virtual Optical Disk File. We're going to select our Ubuntu 18.04 and open. Now we're going to be port forwarding. What are ports? Computers and applications use ports to communicate with each other. For instance, when you go on a web page, it's typically on port 80 or port 443. 80 is unencrypted and 443 is the encrypted version. Your browser knows what port to go to based on the address you give it. Behind the scenes, it's connecting your computer to port 80 or 443 on the web server. In your home lab, you may want to run multiple web servers, so you forward the port you want to the web server itself. In our case, we will be using port 3000. So we're going to click on Network, Advanced, Port Forwarding, and here we go. You'll see this pop up, the port forwarding rules. We're going to add a new rule with the little plus sign over there. We're going to make the host port 3000 and the guest port also 3000. Then we're going to hit OK. Now you'll pop up back here. So let's start our virtual machine. We're going to click on the little start arrow, and you'll see this pop up. For this section, we're going to be using the arrow keys, and to go quickly to done or continue, we're going to use the tab. And no, your mouse does not work, so don't try it. Right when it pops up, it's going to ask you, please select a language. Highlight English, click on that. Go make sure everything's still English. Select done. Now we're just going to leave this the way it is. Click done. We're not going to give it a proxy address, so done. This is going to be just a lot of clicking through dones. Done. Now we're going to use the entire disk now. Okay, done. Done. And here's the only time you really have to use your arrow keys. Instead of no, which is going to be automatically selected, just click the down arrow and select continue. Next, we're going to add our name, our server's name, a username, a password, and we're going to confirm our password. As for a name, add in your name or a name, like Alice Smith. we're going to add our server's name, which you can call it the juice server. Pick a username like Alice. As for the password, pick something simple. For passwords, you usually want to do something super long and complicated, but for our virtual machine, it doesn't need to be that secure. So just pick something like Pizza Cat or Unicorn or something like that, something easy to remember. Make sure to write this down so you don't forget later on. Then confirm your password and select Done. Done. Next, we're going to go down to Done by pressing Tab. Next, we're going to go down to Done by pressing Tab. And now we wait. Once it's finished installing, hit the Enter key to reboot your virtual machine. Then hit Enter again to remove the installation media. Now your virtual machine will reboot. But the first time it boots, it takes a little while longer. And now it's ready. It's going to ask you to log in. Use the username and password that you chose to set it up. Now we need to update the repository. Anything you see in orange, you need to type in. Okay, what is a repository? A repository is where software is stored on the internet. Apt update, in this command, updates a list of your server virtual machines of the latest versions. Then apt upgrade upgrades the software on the computer to the latest version. Next, we're going to install Docker, but What is Docker? Docker is a tool for creating, deploying, and running applications by using containers. Containers put together an application with all of the dependencies it needs and ships it all out in one package. So, let's install Docker. Okay, sudo apt install docker.io. Time to pull JuShop. The docker pull command downloads or pulls the JuShop Docker container from Docker Hub. Now we're going to run Docker. The run command starts up your Docker container. The -p tells which port to forward into the container from the outside. In this case, we are using 3000. Remember that when we set it up earlier, the first 3000 is from the outside and the second 3000 is for the inside of the container. Now open up your web browser. Chrome works best for this application. And go to 127.0.0.1:3000. And bam! There is your JuShop web page, running on Docker inside your virtual machine. The 127.0.0.1 is your machine's loopback address. That basically tells the web browser to look at your machine for the website. 3000 is the port we are forwarding from outside the virtual machine to inside the virtual machine and all the way into your Docker container. Now, take some time to explore JuShop. Just poke around, try buying something, make a fake account. Just poke around and see what you can do. And we'll be back for the next session after a short break.